Hello dear students, welcome to chemistry class. So I might not be familiar to all of you, so let me introduce myself. I am Joann and I am your new chemistry teacher. So let us begin with today's class with the first chapter, Matter and its Composition. So have you ever wondered the things that are there around, what are they made up of? So there are a lot of things around you. For example, if you are sitting in a room, you can have a pen, a pencil, a table, a chair, books, a ceiling fan. Likewise, a lot of things are there surrounding you. Now, what are all these things made up of? All these things are made up of matter. So the basic substance of all the material that is there present around you is matter. Be it a living thing or a non-living thing. Living thing which includes plants and animals, or a non-living thing which includes man-made and natural non-living things. All these are made up of matter. Now, let us see what exactly is a matter. Any object that occupies space, that has mass, and that can be perceived by senses. Now, if an object satisfies these criteria, then we call that object as a matter. Now, let us take an example of a matter. Say a book. Does it occupy space? Yes, if you keep it on a table, it needs a space to sit. If you keep it on your hand, it needs space to sit, right? So it occupies space. Does it have a mass? You keep a book on your hand, you feel that it is heavy. You keep on adding more books on your hand, what do you feel? You feel that it is becoming heavier and heavier. And that itself proves that it has mass. And can it be perceived by any of your senses? Yes, it can be perceived by the sense of touch. This book satisfies these three criteria, so we can say that it is a form of matter. Now, another important thing is that a matter can neither be created nor it can be destroyed. Now, there are few experiments that are conducted, and for you to understand better the law of conservation of mass, I will be sharing an experiment along with this video. Now, let us see three states of matter. Matter has got three states and it is divided as solids, liquids and gases. Example of a solid state of matter, as we have seen, book or this marker, this whiteboard or anything that is a solid object. Now, when I say liquid, the first thing that comes up in everyone's mind is water. Yes, water is a form of liquid and it is another state of matter. Then the third state of matter is gases. So when I say gas, it is air or steam. If you boil water, what do you see? It is the steam that is coming out of the water. So that is a form of matter that is in the gaseous state. So the air that you feel around, that you breathe around, that is also a form of matter that is in the gaseous state. So these are the three important states of matter. All of you know that a solid state of water is ice and a liquid state of water is liquid itself and a gaseous state of water is steam. We have already seen that a matter is any object that occupies space and that has mass. Now, let us prove this by using an activity that is given in your textbook. So, let us go into the first activity to prove that matter, that is solids, liquids or gases, have mass. So, now let us take a weighing machine or a weighing scale to one side of it that is equally balanced now, to one side of it you add a solid. Now what happens? What do you observe? The weighing machine that is balanced has got a tendency to tilt, or it is tilted to one side where the solid is present. It will be tilted to this side. So this shows that it has mass. So what does that conclude? It concludes that solids have mass. Similarly, let us take a liquid this time. On one side of a scale that is equally balanced. Now if you keep a beaker of water, what happens? What do you see? You see that this side of the weighing scale gets tilted to one side. So that again proves that liquid has weight. So what does that mean? Liquid, which is a form of matter, has mass. Then thirdly, let us take the gaseous state. Let us take a balloon that is inflated and let us keep it here on one side of the scale. What do you observe? You see that the one side of the scale where the balloon is placed gets tilted to one side, and that again proves that gases have mass. So now we have proved that solids, liquids and gases have mass. Now let us prove that all solids, liquids and gases occupies space. So for that, let's get into the second activity in order to prove that. Take a measuring cylinder that is half filled with water. Say the cylinder is filled with water up to the point A. Now you tie a thread at the end of a stone and you insert this stone inside this measuring cylinder with the help of a thread. Now the stone is immersed. Now what you can see is that this level of water rises from A to A dash. Say the level of water has risen till here. You mark the point as A dash. Why? Because a solid piece of stone was inserted into the measuring cylinder. So now what you have proved? A stone, which is a solid object, while it was inserted, since it occupies some space inside this measuring cylinder or beaker, it has displaced this water from there, and as a result the water has moved to a new position, that is A dash. Now this proves that solids occupies space. So now let us prove that gases occupy space. So for that, take a huge beaker. Now you half fill it with water. Say for example up to this level. Now you take a tumbler that is empty or a glass that is empty and you insert it upside down into the beaker that is containing this water, and then slightly tilt one end of this beaker. If this is the tumbler that you have inserted, slightly tilt it to one end. Now what you can see is that air bubbles will start to escape from the water. Now what happened here is that the air that is present inside the tumbler, even though you felt that the tumbler is empty, there was air that is present inside the tumbler. It is that air that is pushed out of the water when it was tilted. So this again proves that gas occupies space. Now that we have seen from the activities that matter, all states of matter, it occupies space and it has mass. Now let us see, what is this matter comprised of? all the matter are comprised of small particles or tiny particles called as atoms or molecules or ions. When atoms are combined together, you get molecules. Or if any of the substance loses an atom, then it becomes an ion. Now let us see what is an atom. Atom, the word atom is derived from the Greek word atomos, which was discovered by a Greek scientist, Democritus. Now let us see what is an atom. Atom is the smallest indivisible particle of a matter. Now let us take this example. Let us take a solid block. Now you divide it into two. Now again you take the divided part, again you divide into two. Likewise, again you take the smallest part, again you divide it into two. Likewise, after you divide it, and then you will reach a final stage wherein you cannot further divide it. And that particle that you get, which is indivisible, is called as an atom. So atom is the smallest indivisible particle that is present in a matter. So any substance, if you take and if you divide it up to the final stage up to which it cannot be further divided, then that is called as the indivisible, which means you cannot divide it again. So this indivisible particle that is present in any matter, you call it as an atom. So these atoms will combine together to give you molecules. If any of the atom is lost from a substance, then it becomes an ion. Now these particles, let us see the characteristics. These particles are very small in size. As we saw, these are indivisible. Now they have intermolecular attraction between them. Now if you take a substance, now we have seen that this is a matter that is comprised of small particles called as atoms. Now these particles have intermolecular attraction. These atoms are kept together. Now when atoms are kept together, you call it as molecules. Now as they are kept like this, they have got an attraction between each of these molecules or atom. So we say that it has intermolecular attraction. This is the case that happens within a substance. Now it also has intermolecular spaces. Now you arrange an atom in this way. Atoms are arranged like this. There is space that is existing between two atoms. So you say that it has got intermolecular spaces. And these atoms that is present in the substance, they are always in continuous random motion, which means that they move, they have the ability to move randomly. And any object that has got the ability to move, it possesses some energy, and that energy is called as kinetic energy. Let us see how are these atoms arranged in case of solids, liquids and gases. Now we have studied about solids, liquids and gases are the three states of matter. Now let us see how are these atoms arranged in these different states of matter. First, let's take solid. So in case of solid, the atoms are arranged very close to each other, which means that they are closely packed. But in the case of liquids, these atoms are arranged not as close as that of solids, but little far away than compared to the solids. Now let us see the case of gases. In case of gases, the atoms are not close to each other, but they are far apart from each other. That is how these atoms are arranged in case of solids, liquids and gases. We have seen about the arrangement of atoms in case of solids, liquids and gases. Now let us see about the space between the atoms. in case of solids, liquids and gases. We have already seen that there is an intermolecular space that is existing in the between the small particles. That is, the small particles are molecules, atoms are ions. So in case of solids, let us see how is the space between the atom. These atoms or molecules in case of solids are closely packed, and as a result of which the space is minimum. In case of liquids, the atoms are not as close as in the case of solids, but they are slightly far apart. Therefore, you can say that the space is more than that of the solids. And in case of gases, you see the atoms are far apart from each other, and as a result of which the space between the atom is maximum in case of gases. Now we have also seen that there is an intermolecular force of attraction that is existing between the atoms or molecules. So let us see how is that force of attraction. In case of solids, the atoms or molecules are closely packed, and as a result of which there is a very strong force of attraction. So force of attraction is actually a attractive force which can hold the atoms or the molecules together. So when you say intermolecular force of attraction, it is nothing but the attractive force which holds the molecules together in case of solids and liquids. So now let us see in case of liquids, the force of attraction is very less compared to that of solids. Why? Because in case of liquids, the atoms or the molecules are slightly far from each other, and as a result of which the force of attraction is less stronger, or the molecules or the atoms are not very strongly bound as in the case of solids. In case of gases, as you know, the molecules or the atoms are far apart from each other, and as a result of which the force of attraction is very weak, or there is no force of attraction in case of gases between the atoms or the molecules. Now we have also seen that there is a continuous motion in case of the small particles. So matter comprises of small particles, and those small particles are in continuous motion. Now let us see that. In case of solids, how is the motion? Now they are in a fixed position. They cannot move farther. So what happens? They move in its own position. All these atoms, it moves in its own position. So that is what we have mentioned as the particles, that is the atoms or the molecules of solid, it moves in its own position. In the case of liquids, the atoms are slightly far apart, so they have some space to move. So what happens? They are in continuous motion in case of liquids. Say for example, you take a liquid in a beaker, and if you see the movement of these atoms or molecules, you can see that they move within the liquid. They do not come out of the liquid, but they move within the liquid. That is the case of the movement in case of liquids, that is continuous motion. And in case of gases, you see these particles are far apart from each other. So in case of gases, the movement of these atoms or molecules is that they are in random motion. See, if you take a gas in a beaker, if you try to take a gas in a beaker, you can see that the particles of these gases or the molecules or atoms of these gas, they come out of the beaker, right? They do not stay inside the beaker. Why? Because these are in random motion. Now, you also know that these particles possess some sort of energy due to its random motion, and that energy, because of the motion, you call it as kinetic energy. Now, the kinetic energy will be very less in case of solids. The atoms will have very less kinetic energy because they cannot move. They move only in its own position. In case of liquids, the kinetic energy is slightly more compared to that of solids because they are slightly far apart, and therefore they can move slightly more compared to that of solids. And in case of gases, the kinetic energy will be very high for the atoms or molecules. Why? Because they are in random motion